Hi everyone, I hope you can hear me well. And welcome to this journey through EMBL-EBI's impact assessments. I am Eleni Tzampatzopoulou, I'm an impact manager at EMBL's European Bioinformatics Institute, and today I'm going to be your guide through this journey for the next 10 to 15 minutes. So, yeah, as you can see, I was not one of these kids that knew what they wanted to be when they grew up, but I guess at least I was asking questions and I tried to start finding answers through systematic research and hypothesis testing. At some point, I also realized that I had to repay my student loan, so I had to give up scientific inquisitiveness for the sake of finding ways to grow revenue, both mine and the companies I was working for. But this ended up providing me with some good data analytics skills that actually paid off and keep paying off when it comes to answering questions in a data-driven way. And the question that really stuck with me is, how do we assess the value and the returns of investment of public data resources like the ones funded by the NIH or by EMBL-EBI and other funders? And if these, you could say, they serve as my compass, then let's grab a map to see how we can move further along to assessing impact. This does seem a bit linear, but I don't want you to think of it as a linear journey from resources to impacts. So I like to think about it like there are a lot of invisible threads linking funding data and submitted data sets in one part of the world that lead up to more knowledge sharing and great developments in vaccines for rare diseases or anything else in another part of the world. If we see at the resources there, at least for EMBL-EBI, some of these serve as the data, as the resources that lead to activities, and through these activities and the use of these activities and their outputs, we go on to short-term outcomes and long-term outcomes, like through fair data and open resources, open APIs and global standards and policies. We have increased uptake of these that we hope that are going to be realized into longer term impacts. And now that we have our map, it's going to prove very valuable when it comes to the metrics that we apply when we want to measure what matters. And as the questions we ask grow in more complexity, so do the data and the analytics we have to use in order to give answers to these. So we might start by internally taking a look and tracking the grants data, the position volumes, and the compute power we have. But going down the line, when we want to see how we are influencing the short and long-term outcomes that we want through our activities and outputs, we have to apply more complex methods. Some of these that I'm going to talk about are economic analysis or engagement with the industry, and we hope that we will keep building on this by combining this in order to take a look at in order to go closer to taking a look at the impacts and not only the outcomes. But yeah, now that we have our compass, our map, and some of the measurement tools, let's go and see how this could be done in practice. As you know, biodata resources are a community effort, and we wouldn't be here, the biodata resources wouldn't be here without the contribution of our collaborators and data submitters. A lot of them are in this room, I guess. And if the life science ecosystem is a global endeavor, then with millions of researchers and innovators and clinicians contributing, then EMBL-EBI's role is to provide the infrastructure in order to enable these scientists to contribute and other scientists to build upon these contributions. Here we see a graph of the volume of depositions that come in EMBL-EBI, and only in 2023 we had over 15 petabytes of data coming in. And if we want to give light to some of these numbers, I have two examples here. One is of the Bioimage Archive, is one of the most recent biodata resources that stores bioimages, and it is not a standalone resource. It has a lot of links, both with internal resources like the biostudies and biosamples, and it also has data flows with external resources. Recently, only last year, the Human Protein Atlas deposited over millions of images that amounted to 300 terabytes. This is a huge contribution, and now we have data that don't sit in silos, but can be accessed in many different ways by many different people to achieve things faster and at more scale. Another example comes from the European Genome Phenome Archive. Recently, a few months ago, the Wellcome Sanger Institute researchers deposited over 46 terabytes of sequencing data that came from 3 UK cohorts of birth study cohorts. And now having this data along other in the European Genome Phenome Archive makes them interoperable. People have access to longitudinal study data that can inform research of child development and health over the years. But of course, these data we don't want the data to just sit on servers. We want people to access them and use them. And one way to track this is through the unique IP hosts or addresses that visit EMBL-EBI resources. I think Fabio in his presentation also showed some different metrics. And again, behind these numbers, we have real world stories like these two examples. The first one is an LLM-based agentic AI that democratizes access to models of biological interactions. Computational models of biological interactions, and it has links with many EMBL-EBI resources. And another one comes from Magnify, a great presentation given a few hours ago. In this case, researchers use Magnify data in order to find bone degrading and waste degrading enzymes that could be upcycled into protein for consumption. And other enzymes that could be found are plastic degrading enzymes. This way, when this knowledge is being used by other industry players and collaborators, can create tools that will help to address issues, pressing issues. Another way we take a look at what is the imprint of our biodata resources is through taking a look in the literature. Here is a chart showing the mentions of EMBL-EBI resource names and accession numbers in EuroPMC articles. This is happening through a text mining pipeline that has been developed by the EuroPMC team. And one example that was found through that is how the gene to phenotype data resource has been identified as a trustworthy source of clinically relevant variants data by the UK Association for Clinical Genomic Science. I have mentioned a lot of different metrics, some of them quantitative, and then the use cases that go to the qualitative side of things. What I want to highlight before going on is that for all of these, there is consistent need to improve, maybe enhance with metadata, and always try to figure out if there are any other measures that show the impact we want to realize in a better way. And on the other hand, and for this to be done, we have to collaborate a lot with our IT teams and other players within the organization. On the other hand, the use cases are a bit difficult to develop, although they give amazing examples of how impact is being realized in the society. Finding the leads is quite difficult. It requires a lot of communication and collaboration with different stakeholders internally and externally. So they might be a bit time consuming to develop. So, however, although we're working differently on these work streams in order to find better ways of dealing with this, another another way to showcase feedback and maybe gather more of these stories is through surveys. EMBL-EBI has a long-standing history of conducting surveys, and we had to stop at around COVID, but we relaunched our surveys back in 2024. These are the findings that came up from this survey last year. We had over 2,300 responses, which I believe is quite good for it corresponds really with our user base. It had good representation, not only geolocation-wise, but also across sectors and across scientific domains. With surveys, apart from being able to ask people both for quantitative things, and we also are able to ask them for written feedback, open-ended feedback. And this is a way that we manage to get a lot of good stories, and also try and test new things. In this case, for example, it was the first time that we tried to conduct sentiment analysis from the survey responses. This is specifically an industry cut of the survey, but we are also able to do different cuts for different audiences that are of interest, and see how the usage shifts over the years. And I just wanted to add here an example of another collaborative endeavor. The AlphaFold DeepMind, as we all know, was trained on these EMBL-EBI data sets, and the interaction didn't stop there, though. And this is the good thing that open data and open biodata resources can contribute to with their expertise in managing large data sets. So the AlphaFold database was designed between the Google DeepMind team and EMBL-EBI teams. It now hosts the protein predictions that come from the algorithm, is used by a lot of researchers, and also the EMBL-EBI training team has co-developed a training course in order to train more researchers on how to use this resource in a way that can provide innovation and answers to pressing problems. Also, this database is interoperable with other external and internal resources, and this is how we see open data going to fuel innovation, and then this innovation can trigger people to train and get more innovation and more data back to the system in a way that is sustainable. Another example of what the survey in 2024 provided us with is examples of how and of what scale is the downstream usage of EMBL-EBI products. And it was the first year that we also added an option as to whether people started training AI or ML models with our data. A recent example found here. So this is a very recent example that we cannot really see in a lot of detail if the impact that we would like to have is achieved, but it serves as a good reminder that it is good to start tracking things early on instead of trying 3 years later to look for examples of how our data have been used. I think it is better if we start tracking things more consistently and be aware of the journey of our data from early on. I have showed a lot of numbers and a lot of growth and scale in many occasions, but what I want to highlight here is how the important thing sometimes is for us and for the biodata resources to just support this one team in order for them to be able to support thousands of people every month. In this case, different practices of biodata resources like Ensemble, different research and the research of research teams at EMBL-EBI and standard setting co-developed by EMBL-EBI has supported the NHS Genomic Medicine Service in collaboration with Genomics England to provide genetics testing and results every month. Again, this is to highlight that it is extremely difficult to build these case studies, but I think that when done, and they also can trigger long-standing relationships, and an opportunity for both sides to try and develop more sophisticated methods of proving feedback, proving the impact that their services produce. And this is what we have been trying to do for the last years through our economic impact studies. The first one ran in 2016, the second one in 2021. Some of the results can be seen here. And we are running the third one this year. I'm going to come back to this in a later slide. In this 2021 economic impact study, of the economists that we worked with took a look in various different quantitative and qualitative metrics, from use value to contingent valuation and the efficiency impacts. It was found that biodata resources have a lot of returns in gains and a lot of benefits in time saved and research enabled that would otherwise have not been possible. But it also comes with challenges, survey fatigue being one of them. We see decreasing trends of responses from the community that could be attributed to various different reasons, but it is a reality that we have to find solutions to. And then the complexity of data collection is another one, especially when it comes to costs of databases that run collaboratively. And then the weakening of counterfactuals. We are in an increasingly open world, and it might be difficult for people to assess what it would have been like if they didn't have access to this data. But these are maybe challenges that we have to work with going forward. This is a closing slide on AI's impact, let's say, if I may add, in impact evaluation. There are many opportunities, and as I've mentioned, I have already used it in my work for a few things. Still testing, still fine-tuning. It allows us to do things that we were not previously able to, but always with the challenges that we have to balance and without over-relying on them, because we don't want to miss any high-impact cases that might not be well represented. And we don't want to miss fine details of qualitative impacts. Thank you so much for listening. This is a QR code to the survey of 2025. I talked about survey fatigue, I know, but if you had 10 minutes and you would like to have your input and provide examples of how you use our data resources, it would inform the impact study of this year that's going to be published and open for everyone to read. Thank you so much.
Maybe time for just one quick question. I'll ask one very, it's a bigger question, but I'll ask it anyway. So you said that you used the phrase weakening counterfactuals, and I guess that's kind of the counterpoint to the point I made about building a network, right? Whereas if the network is resilient to perturbations, then that also means that any one resource perhaps weakens their counterfactual. That's something that you're looking at in the EBI context? So.
And I think this is something that we're going to explore in this economic impact survey. We don't believe that we're going to have to face that now, but it might be something that we're still not having started looking at the survey results, of course, because the survey is still running until the 24th. But I think this is something that we will have to look into and start maybe addressing early on if we want to keep building measurements and analytics and methods that prove the impact going forward.
Thank you again. Thank you.
Thank you.
So let's get back on.